Okay, so here we've got question 5, and we've got a geometric problem where you've got a cyclist going 2.3 kilometers due north from point P, and then changing direction and cycling 1.8 kilometers on a bearing of 105 degrees in order to get home to meet his friend. So we've got the 3 places marked, and we've got a sketch diagram drawn, and the idea now is part A, how far are they from the park measured directly? So we're talking about this direct distance from P to H. So we're thinking about what we know about this triangle. We know that that's 75 degrees. And we know that we can use the cosine rule because we have the opportunity to get this side when we have that angle sandwiched between 2 known sides. So we've got c squared equals h squared plus p squared minus 2hp cos of the angle C. So putting in our numbers, we've got h squared, which is 2.3 squared, plus p squared, which is 1.8 squared, minus 2 lots of 2.3, 1.8 cos of 75 degrees. Putting that all together, we're going to end up with c squared equal to 6.38, 697, so c is the root. It's about 2.527 kilometers. Moving on to part B of the question, we've now got to find the bearing that he needs to take to get back to the park. So we're talking about a north line existing here, and the bearing angle being measured from the north line to the line with the park. That's our unknown. Now, if we can get these 2 bits, then we can definitely get that angle, because we know this adds up to 360. So the first bit I'm going to get is this piece, so this angle here. And I'm going to use the triangle CPH to get it. So that angle I'm going to call CHP. And that's what I'm trying to get. So I'm going to use the sine rule because I've got one angle, and I now know that side, and I've got another angle that I'm trying to find, and I know the opposite side. So I've got the sine of 75 degrees over the opposite side, which I've just worked out, so that was 2.527, equals the sine of the unknown angle I'm just trying to find, CHP, divided by 2.3. So rearranging that to get the sine of CHP, I know that I can get the sine of 75 divided by 5.27 and multiply by 2.3, and that becomes 0.879. And then I'm going to do inverse sine to get the angle, which is 61.5. So the bearing angle, remember the bearing angle was that angle that I was taking from the north line right round to that side, can now be worked out, because I know this part is 61.5, this part is 75 using alternate angles, so I'm there. 360, take away the sum of 61.5 and 75 degrees, giving me 223.5 for the final bearing. Now to get the area enclosed by the triangle, I'm going to use the formula for area of triangle for part C. Area equals half 2.3 multiplied by 1.8, the sine of 75 degrees, which is 1.999 centimeters squared.